Hello Year 8, welcome to Year 8 Chemistry. This is our first lesson of chemistry for the lockdown work. We've been doing biology the last few weeks. Today we're going to start off with what is an atom. So if you haven't already got yourself a piece of paper and a pen to write your notes down with, please do that now. Just hit pause on the video, or if you're typing your notes up online, make sure that you've got a new save file ready so that you can upload them onto Microsoft Teams later. The starter question just says, what are atoms? And I really just want you to dump down everything that you know or you have learnt about atoms already. There's a picture to give you a bit of a clue. And the super challenge is, why do we draw atoms as circles? What might have fueled that idea that that was the case, that that was true? Okay, good luck. We'll go through the answers in a second. Right, I can't predict what you've put about what is an atom, so hopefully you maybe know a little bit about the shape of an atom. You might know a bit about the subatomic particles, the smaller bits inside of an atom. You might know their names, proton, neutron or electron, even their sizes or their charges. If you do, fantastic. We'll cover those again today just for some revision. You might know that they're very small, one of the smallest whole parts that makes up a substance. Maybe you've drawn solids, liquids and gases, and again we'll have a look at those in a second too. The super challenge says, why do we draw atoms as circles? And actually the word atom comes from a Greek word atomos, which means uncuttable or undividable. And really when the word was made, atomos, uncuttable, we just chose a shape that was round, spherical, because if you try to cut something that's spherical, it's very difficult to cut it in half because it just rolls away. And that seemed to fit the idea that atoms were hard to break, which we'll talk about a little bit later on. So the main learning objective today is to learn to remember the structure of an atom. Some of you might have a clue about this already, and for others this will be new information. We're going to start by stating what atoms are. We'll describe the structure of an atom, and then hopefully we'll go on to explain the difference between the words atoms, ions and isotopes. We have some new vocabulary today: atom, ion, isotope, electron and neutron. Okay? Right, okay, so to get started, let's talk about what an atom is. An atom is the smallest whole part of an element. I'd like you to write that down in your notes, please. So atom, the smallest whole part of an element. There are a few key parts to that definition. They're the smallest whole part. So we're not talking about once it's been cut or anything that's inside of it. As a whole, the atom is the smallest part of an element. An element is what we find on the periodic table of elements. Elements are substances made up of only one type of atom. So we might have hydrogen, which is an element only made up of hydrogen atoms. Sometimes we use the word particles when what we really mean are atoms. So particles, you can see on the picture on your screens, we have particle diagrams of solids, liquids and gases. These circles are really representing the atoms that make up the solids, the liquids and the gases. Everything around us is made up of atoms. You might have heard that terrible joke, was it don't trust an atom because they make everything up? And that is true, that is the case. Atoms make up everything we know, and what we're looking at on your screens at the moment now is a picture made using a really powerful microscope. Using a quantum microscope, we can see individual atoms. We can't see them very clearly, and they do almost look to be spherical or round. And in this particular picture, someone's made what looks like a man or a boy playing football out of individual atoms, but they need a really powerful microscope to be able to do that. So everything is made up of atoms. But what are atoms themselves made up of? So far on Earth, scientists have discovered over 118 different types of atoms. So these atoms are all different from one another. And all of the different atoms that we've discovered are all included on the periodic table. So the periodic table really is just a map of all of the different atoms that have been discovered on Earth. And one thing that I think is really interesting is that every sample we've ever taken from outer space, from the moon, from Mars, from asteroids and meteorites that have hit and collided with Earth from outer space, all of the atoms that make them up are the same as these 118 atoms that we've already found on Earth. And it's just a good indicator that everything that's out there, out in space, is all made up from the same building blocks, the same atoms. Atoms are made up of 3 different parts. We call these parts subatomic particles. So they're smaller than atoms, and they're particles themselves. There are protons, neutrons, and electrons. You might have heard these words before, you might even know a little bit about them. One of these subatomic particles has a positive charge, one has a negative charge, and the other is neutral. It has no charge attached to it at all. Based on their names, which one do you think is which? Which one do you think is positive? Which one do you think is neutral? And which one do you think has no charge? Pause the video for a second now and have a little think which one you think it might be. Okay, well done if you were correct. Protons are positive, neutrons are neutral, and electrons are negative. The easy way to remember that is P for positive, N for neutral, and then E for negative. Doesn't really fit, it's the odd one out there, electrons being negative. Think like a proton, always positive is another way of remembering which subatomic particle is positive, which one's negative, and which one has no charge. We're going to have a little look in a second at the structure of an atom. So if you haven't done so already, can you write down the name of the 3 subatomic particles and their respective charges? And you might want to, whilst you've got the video paused, grab a pencil ready for the diagram you're going to have to draw in a moment. Okay, so as mentioned, we're going to copy out the diagram that you can see on your screens to show the structure of an atom and its subatomic particles. Start by drawing the 2 circles that overlap, the 2 ovals, and then drawing the protons, neutrons and electrons in as well. Be really careful, because can you see that the electron, the size of it is smaller than the size of the protons and the neutrons. Also be sure to make sure you label the proton as the positive one and the neutron as the empty circle that has no charge within it. Okay, hit pause on the video if you need to, so you've got time to copy out that labelled diagram. Right, okay, now we've had a little bit of time to learn about atoms and their subatomic particles and their charges. We're going to take a moment now to a bit of a history lesson, if you like. John Dalton was an English chemist, not chemistry, was an English chemist, and actually there's a street in Manchester called the Sir John Dalton Street. If you ever find yourself in Manchester in the near future, keep an eye out for it. He mentioned and came up with a lot of the ideas that our current ideas about atoms are based on, and this is a paragraph that he wrote about atoms. It says, "Atoms are the smallest pieces of matter. They are made up of a solid, indivisible and indestructible building block. While all atoms of an element were identical, different elements had atoms of differing size and mass." Now that statement from Sir John Dalton, some of it's true and some of it's not true. And what I'd like you to do is I'd like you to criticise this statement. What criticise? When you criticise somebody, you say something, you kind of pull apart what they've said, and you say, oh, I like this bit because of this, or I don't like that bit because of that. And what I'd like you to do here is I'd like you to perhaps use the colours that are on the paragraph, but also the words themselves. Can you have a look through that paragraph, and knowing what you know about atoms, pull out any bits that you think might not be true, or pull out some of the bits that you think John Dalton got right about atoms. So when we criticise a statement, we say what's good and what's bad about it. Okay, I'd like you to hit pause on the video now so you've got time to do that, and we'll go through some answers in a moment. Right, when we criticise something, we say what's true, what's good about it. So what I like about Sir John Dalton's statement here is the second part. While all atoms of an element are identical, that's true. Elements are made up of only one type of atom. We mentioned that earlier on. Different elements have atoms of different size and mass, and that is true too. So a hydrogen atom looks the same as another hydrogen atom, but if a helium atom looks different, it's slightly bigger and is slightly more massive than a hydrogen atom. If we're going to criticise this, we've also got to pull out the bits that we don't like, that might need changing. When John Dalton said that atoms were made up of solid, indivisible and indestructible building blocks, that's not quite true. We don't know if they're solid. We know that there's a lot of empty space within an atom, so saying they're completely solid is wrong. Indivisible, we know that subatomic particles now exist, protons, neutrons and electrons. In just Sir John Dalton's time, he didn't know that those existed, so those bits aren't correct. They're not the smallest pieces of matter, they're the smallest whole pieces of matter. So he's almost correct with that first part. Well done to you if you were able to comment and criticise any of those bits just as I've done. If you weren't, hit pause on the video please and add those corrections down to your notes. There's the extension task at the bottom here. It says, how do scientists come up with new ideas? It tends to be come up with a theory, test that theory, and then adapt it and move on based on new knowledge. And that's how we do most things in science. We come up with theories, and as we learn new information, we adapt and change those theories. It's 100% okay to be wrong in science as long as you learn from it and you adapt from what you've learned. Okay, to really understand atoms, we need to get a concept of size, so you're going to have to do a bit of imagining for this bit. I want you to imagine a football stadium. I know this is an American football stadium, but for the British equivalent, think of any giant professional football stadium you can think of. If an atom was the size of a giant football stadium like this, and we wanted to find the nucleus, where the protons and the neutrons are, it would be in the middle of that stadium. Based on the whole size of an atom, the nucleus, if the whole atom was the size of a stadium, the nucleus would be the size of a single green pea. So if we got a pea from this pea pod and we dropped it in the middle of a stadium, that's the size that the nucleus would be inside of the atom. Most of the atom, most of the stadium would be empty, and most of an atom is empty space. If we wanted to think about the electrons that are whizzing around the outside of the nucleus of this atom, we'd have to think of a grain of sand, okay? One single grain of sand, and that's approximately the size of an electron as it would be shooting around the outside in shells. And think about the size of a grain of sand compared to the size of a pea. A grain of sand is about 2,000 times smaller than a single pea. And that's true for electrons, they're about 2,000 times smaller than the size of the nucleus. Now this, interestingly, isn't actually a grain of sand, it's a picture of the world's smallest computer, computer camera, which I'm reliably informed is the same size as a grain of sand, which is why I've included it. Okay, I'd like you to grab a pencil and a ruler, or a pen and a ruler, so we can copy out the table below. And what this does is it breaks up the three subatomic particles, neutrons, protons and electrons, and it's going to give you a little bit more detail about each of them. So neutrons, we already know, have a neutral charge. We say their mass is 1, and their position is they're found in the nucleus in the middle of the atom. Protons, we know that their charge is positive, so we say they're plus 1, positive 1. Their mass is the same as a neutron, so we say they're 1-to-1 ratio, they're the same. And their position is also found within the nucleus in the middle of an atom. Now electrons, they're negatively charged, so compared to a proton, they're -1. Their mass of an electron is tiny. Sometimes we say it's 0, it's so small it's almost nothing. Or if you do 1 divided by 2,000 on your calculator, that tiny number you get is the mass of an electron. The reason we say 1 over 2,000 is an electron is 2,000 times smaller than that of a neutron or a proton. And they are found in shells that go around the outside of the nucleus. Make sure you've got all of that information copied down into your table and hit pause if you need to. Okay, so this little bit here is by far the most complicated bit, so don't worry if you need to pause the video and re-watch this bit to understand it. Just to remind you, we've mentioned already that atoms are made up of subatomic particles, and there are 3 that you need to know about. They're called protons, which are positive, neutrons, which are neutral, and electrons. We've said that electrons are the smallest of the 3 subatomic particles, and they go around the outside of the atom in shells, and the protons and the neutrons are found in the nucleus down here. The number of protons in an atom never changes, okay, it is fixed. So the number of protons always stays the same. The number of positive charges stays the same. But sometimes reactions can happen to an atom that makes some of the subatomic particles change. Now, whilst the number of protons never changes, the number of electrons in an atom can change. It can increase and it can decrease. It can be due to a chemical reaction or something else happening. And when the number of electrons inside of an atom changes, we call it an ion. So if we had an atom of oxygen and it gained an electron or it lost an electron, we wouldn't call it an oxygen atom anymore, we'd call it an oxygen ion. And by changing its name to an oxygen ion instead of an oxygen atom, it's our way of letting people know that the number of electrons within it has changed, either increased or decreased. Now, if you lost an electron in oxygen and the oxygen atom became an oxygen ion, and then you put another electron back in its place, so the number goes back to what it was originally, we can call it an oxygen atom again. Now, along the same lines, the number of neutrons inside of an atom can change too. Because they're neutral and they have no charge, it doesn't really make much of a difference to the charges inside of the atom's nucleus. So some processes can change the number of neutrons within an atom, and when the number of neutrons is different to what we'd expect, we call it an isotope. So an isotope is when an atom has a different number of neutrons but the same number of electrons and protons as we'd expect. And an ion is when an atom has an increase or decrease of electrons from what we'd currently expect. And that ends up giving the atom an overall charge, but you'll learn more about that later. Okay, quiz time, just to check that you have been listening, paying attention, and you've understood what we've gone through. You've got 30 seconds to answer the questions on your screen. Off you go. Okay, hopefully you had time to get all of those done. Question 1, which was which two subatomic particles are the same size? Hopefully you've said protons and neutrons. A better question would have been the same mass. Number 2, which subatomic particle is found in shells around the nucleus, around the outside of the nucleus? That would be the electrons. How many different atoms are there? Around 118. It's the number of different atoms we see on the periodic table. At the moment there are 118 different atoms that have been discovered. What is an ion? An ion is an atom that has gained or lost electrons, so that it has gained or lost a charge. What is an isotope? An isotope is an atom that has a different number of neutrons, but the same number of electrons and protons. Okay, your final job for today, and this is the work that I'd like you to upload onto MS Teams or to email to your science teachers at Cowley, is to make a poster to display everything that you've learnt today about atoms. The more detail, the better. So you must include a labelled diagram and at least 5 other facts from today's lesson. If you want to include more than 5 facts, then fantastic. Do a bit of Googling, see what you can find out about atoms. A little bit about their history would be fabulous, because we'll cover that in a later lesson. Use some pictures on the screen now for inspiration, and don't forget that, as always, you need to take yourself over to Educate to complete the Educate quiz that goes alongside this lesson. Okay, make sure that you upload your work onto Microsoft Teams if you're using that. If you're not currently using MS Teams and if you're having any difficulty, then just drop us an email and we'll try and get you sorted. So hopefully by listening along today, you can now say what an atom is, you can describe the structure of an atom, and you can explain the difference between atoms, ions and isotopes. Thanks for listening, and we'll be back next week with more chemistry.